Hello everyone. I am Chirag Bellara, a junior data scientist at the Laboratory of Data Science at Purdue University, Fort Wayne. I will be talking about a topic that is rather interesting but not talked about enough. This topic, I believe, is something not many people would have actually heard of. The topic is called as digital twins. So in this video, we will essentially be going over what a digital twin is, where does this concept actually originate from, what was the reasoning behind such a thought, and some basic how does it actually work. And you see, there is this concept of simulation that almost all of us are aware of, and what essentially is the difference between the simulation that we know and the digital twin that not many people actually know about. In another video, I would be discussing the applications of the concept of digital twins in the fields of in industrial fields, and I will be talking about the challenges and the limitations that we currently face when it comes to developing digital twins. So, what exactly is a digital twin? So, if we speak in very layman terms, a digital twin is nothing but a replica of any object that exists in the real world. So, anything. It's like uh, you take something and you make a copy of it, that essentially becomes a digital twin. But when we talk about a more technical definition of the term digital twin, we can say that a digital twin is a virtual representation of an object or a system that constantly gets updated with real-time data, and it uses some kind of simulation techniques and alongside machine learning to analyze the behavior of systems and to provide insights for future and to predict occurrences, and there are like several applications to it. But overall, we have a physical object, we have a copy of the physical object in the virtual world, and we have a way in which this virtual object communicates with the physical object and constantly gets updated with new data. And we use this virtual object in order to, and we run like basic, we learn not basic, but we run like machine learning algorithms and several simulation techniques in order to derive insights from this virtual object, which can be implemented onto the physical object. So the question is, do we really need digital twins? The short answer is yes, we definitely do. Uh, why? Why do we actually need digital twins? So all in all, digital twins have proven to be extremely useful in terms of increasing efficiency, optimizing processes, and saving a lot of operational costs. Digital twins can also be used to perform effective predictive maintenance, mitigate any potential risks, and not just that, in fact, they increase how much we actually know about a system to a good extent. We essentially have a copy of an existing system, and we can run as many tests as we want. We can experiment with this virtual copy and see how a system behaves. So we get to know more about the internal working of a system through a digital twin. Okay. Coming to the history, where did this concept actually originate from? So, uh, though this term digital twin was first coined in the year 2010, the concept of digital twin was not new. It had been, in fact, it has been as old as 1960s. So NASA has been using the concept of digital twin since 1960 when they created a replica of the Apollo 13 spacecraft. And if there were any problems on the Apollo 13 spacecraft, they essentially recreated those problems on this replica and tried to find out a solution when they were when the Apollo aircraft was on mission, and we were like we could not run as many tests and as many simulations on the real aircraft. So since 1960s, the the topic of mirrored worlds was introduced by Professor David Gleitner, and it essentially represented the same concept, maybe like a different version of it. However, It was in the year 2002 that Dr. Michael Greaves officially proposed the idea of a digital replica. He titled it Mirrored Spaces Model. Uh, this concept was later proposed by a similar concept, not exactly the same, but a very similar concept was later proposed by several other academic institutions across the world. And in the year 2006, this concept was officially known as the information mirror model. And then in the year 2010, NASA used the term digital twins for the first time in their technological roadmap for the year, wherein they defined the term digital twin as a copy or a copy of a physical object into a virtual world which constantly gets updated with real-time data. Ever since NASA has utilized this has introduced this concept of digital twins, there have been several projects that have been started by big organizations, academic institutions across the world. One of those uh, early projects that really gained a lot of traction was the Digital Singapore project, which was launched in the year 2014 by the government of Singapore, where they essentially wanted to create a replica of the entire country of Singapore. Uh, and not just that, in the year 2018, there was a National Digital Twins Day that was announced in the UK, which I mean, compared to like the introduction of the topic in 2010 to where we are right now, digital twins has gained a lot of traction, but there is still a lot of innovation and experimentation and research that is there to be done, I guess. So moving on to the framework. So essentially, what is a digital twin? As I said earlier, that a digital twin has a real product, a physical object, a virtual model or a virtual product or a digital twin, and then we have a connection link between the two, which essentially which is the way the virtual model uh, communicates with the physical object. And so what does the physical object do? The physical object gathers data, parameters, working conditions, and environmental conditions, and passes on all this data onto the virtual model. So the virtual model replicates all these conditions and runs tests and analysis and uh, and gathers insights. And so it essentially runs a lot of simulations on these specific conditions to identify how the object would behave in these conditions, the parameters, and uh, it gets results and the updated parameters for efficient functioning and transfers all these back to the physical model, and the physical model updates the physical object updates itself, and hence like this process goes on for the entire lifetime of the object. So essentially we have a physical object that constantly gets updated with the insights that are created by the virtual model in order to give us the best and the most optimized functioning possible. Coming to uh, so I said that digital twin uses simulation techniques. So what exactly is the difference between a digital twin and a simulation? Definition wise, they both sound very similar. However, the difference comes on the aspect of the presence of a data connection, but in the digital twin, whereas a simulation does not have that. So essentially, a simulation is static. So that means that once you create a simulation, it does not get updated over time. Whereas a digital twin is very active. It constantly gets updated with new data, new parameters. Um, it keeps on getting updated based on all the conditions that we talked about, the environmental conditions, the internal conditions, the working conditions. Another difference is that a simulation represents what could be possible for the model, for any object. So it does not talk about the ground truth, it talks about a possibility. Whereas a digital twin talks about what is actually happening with the physical object right now. So a digital twin gives us more realistic and more uh, objective look at a physical object as compared to a simulation. So that's it for this video. In the next video, we will be talking about the applications of digital twins in the industry and some challenges and limitations that we currently face with the development and research in the field of digital twins. This project was supported by the Laboratory of Data Science and the Indiana Data Mine Grant and supervised by Professor Alessandro Selvitella at the Purdue University, Fort Wayne. Thank you.